Okay, good morning class. At this point you're looking at exponents and surds. We are on exercise. Let's check here. That is done. Yep, here we go. Rationalizing the denominator. We're looking at the examples for exercise 1.10. Is that correct? Right. So at this point, if you want to see the full lesson, you'll find it in the description box below. Exercise 1.10 is on page 20 or 19? 20. Right. So it's usually more accurate and more convenient to write your answer with a rational denominator. Okay, that's hence why it's called rationalizing the denominator. Okay. Remember that the square root of 2 times the square root of 2 is 2, and the square root of 2 over the square root of 2 is 1. Okay. So we're looking at the examples. The example is on page 19. This is the example, page 19. Okay, so the question says, write the following with rational denominators. What do you notice here? We notice that the denominator is surds, yes, square root of, which is rational or irrational? Irrational. So currently the denominator is irrational. We want to rationalize the denominator. You guys understand? Alright. So if you're looking at 1 over square root of 2, to get this to be rational, what I do is I multiply this by the square root of 2 over the square root of 2. Remember, if I multiply this by the number 1, am I changing anything here? No. But then 1 I choose, in this case, I choose it strategically to be the square root of 2 over the square root of 2. So you say, okay, 1 times square root of 2. What's 1 times square root of 2? Square root of 2. What's the root 2 times root 2? You see? 1 multiplied by root 2 is root 2. Root 2 times root 2 is not 1. The square root. It's going to be the square root of 4, which is 2. Do you guys understand? Alright. So let's look at the next one. Number 2. What must 14 over root of 7 be multiplied by? Root 7 over root 7. As you know, root 7 over root 7 is 1. Right. So what is 14 times root 7? 14 times root 7. 14 root 7. Not so. Over. What's the square root of 7 times the square root of 7? 7. Yes, nice. Now what can we do? We can simplify it. Not so? 7 goes into 7 once, 7 goes into 7 once. You all agree with that? Yes. No. Don't just say yes. Imagine somebody just walk past, would you marry me? You just say yes. It mustn't be like it. No? You first say no couple of times and then you see. Right. 7 going into 7 once, 7 going into 14? Twice. So it's going to be 2 root 7 over 1, which is 2 root 7. People, you guys understand? Right, let's look at number 3. Number 3. You got 5 over square root of 5. What must that be multiplied by? Square root of 5 over the square root of 5. You all agree with that? Why are we doing this? To rationalize the denominator. That is why. Currently the denominator is irrational. Okay. What's the square root of 5 times 5? 5 root 5. Over. Square root of 5 times square root of 5? 5. So what can happen now? 5 into 5. There we go. Which gives you square root of. Okay, who's confused? You all understand? Must I do it again? You just said now you're not confused. Now I must do it again. Are you confused or not confused? Yeah, but then you mustn't be like it. I'm going to pause the video at this point. And I'm going to do it again, okay? Why? So I like doing maths. Right. Carry on with our lives as if nothing happened. You guys are very good at that. You tell yourselves, no, don't worry about this, man, I'm going to figure it out in the exam. No? That is a common phrase that you guys tell yourself. You win this now, you'll get it in the exam. No? Yes, he's nodding yes. Okay. Just don't repeat the result of last year. That's better, isn't it? People number 4. Is that denominator rational or irrational? Irrational. Okay. So, if you're looking at that there, what do you think I want to multiply this by? Root 3, no? Over root 3. That's what you want to say. Let's see if you're right. What is 5 times root 3? 5 root 3. Over. 2 times root 3? 2 root 3. Root 3 times root 3? 3. It's almost as if we solved the problem, but the problem actually got a bit bigger or worse. So in this case, I'm not going to multiply it by root 3 over root 3. However, if I got 2 plus root 3 and I multiply by this by its conjugate pair, which is 2 minus root 3. You guys know the difference of 2 squares, no? Yeah, that is it. So what's going to happen here? I can multiply the first and the last. Okay, you guys understand? No? Don't tell me when I'm done with both sums you don't understand. You understand so far? Right. So what's 2 times 2? 4. What's positive times negative? Negative. Root 3 times root 3? 3. Rational. Oh. So, which means to say, let's put that into play. Let me go again. So this we will multiply it by its conjugate. And the conjugate of 2 plus root 3 is going to be 2 minus root 3. And what must go on top? 2 minus root 3. Why must the top and the bottom be the same? Because it's equal to 1, yes. You all agree with that? Is nobody's confused now, no? Right. So what we do is we multiply the first and the last. So that would give you 2 times 2 is 4. Just align the board quickly. I'm not playing games with myself. Stuff is just jumping around, okay? Let's try again. Okay, so 2 times 2 is 4. Negative root 3 times root 3 is negative 3. Then I multiply the top of it. So it's 5 into 2 minus root 3. Okay. So what's the 4 minus 3? So the denominator is 1, not so? So anything over 1 is that number. So that's simply going to give us 10 minus 5 root. Okay. Do you have to put the arrow there? No. Okay. Do you understand? No. So since you understand, you can do the next one fast. How about that? Yes. This is just to make sure you understand. Okay. So you got 4 over square root of 7 minus 2. What are we going to multiply this by, Michael? Yes? Yes, well done. And you definitely understand. What goes in the numerator? What? Oh, see, this says plus. Sorry, man. My eyes. Right. Go for it. What goes in the numerator? Same? Yes. Why the same? Because of the square root of 7 plus 2 over the square root of 7 plus 2 is 1. Yes. Now what? Multiply. The first times the last. So that's simply going to give us root 7 times root 7? 7. Negative 2 times positive 2? negative 4. And we got 4 into square root of 7 plus 2. What is 7 minus 4? 3. So the denominator of 3. Now you see that 3 doesn't simplify with that 4. Can you see that? So what I do is I multiply it. If we add, if you could simplify this 3 with that number in front of the bracket, then I simplify the number first before I multiply them. Does it make sense? This is number. Okay. So say for instance this was a 6 instead of a 4. Say that was a 6. Then I would have written 6 into root 7 plus 2. 3 going to 3 once, 3 going to 6 twice. Then I multiply 2 root 7 plus 4. You understand? But in this case it's not a 6. What is it? It's a 4. So is 4 divisible by 3? No. Well, there's no factor that goes into 4 into 3 without a remainder other than 1. Can you see that? Because that is the case, what do? I multiply this in. So that's going to give us now 4 root 7 plus 8. Do you guys understand? So do that one again. No. Who said I was doing it again? You don't have to, are you scared now? No, okay. Right. So with that, you should be able to do exercise 1.10. And 1.10 is on page 20. You can do for me the odd numbers now. Check your books.